Hello, bachcho. Let's read the question. The question says here, what is given a vector plus b vector plus c vector plus d vector is 0 vector. So which of the following statements is not correct? Okay, let's find out. So statement A says a vector, b vector and c vector and d vector must each be a null vector. Okay, so in order to make a plus b plus c plus d plus uh, c plus d is equals to 0, it is not necessary. It is not necessary to have all the four given all the four given vectors to be null vectors to be null vectors. Okay, there are many other combinations which can given the sum 0. So option A, bigger button, statement A is incorrect. Okay, and B says the magnitude of a vector plus c vector equals the magnitude of b vector plus d vector. Okay, so a vector plus b vector plus c vector plus d vector is equals to 0. That means a vector plus c vector is equals to minus of b vector plus d vector. Okay, so taking modulus on both the sides, we get a vector plus b vector c vector. Okay, uh, and mod of b vector plus d vector. So that will be b vector plus d vector. Okay, so hence the magnitude of a vector plus b vector is the same as the magnitude of b vector plus d vector. So statement B is correct. Okay, so statement C says the magnitude of a vector can never be greater than the sum of the magnitudes of b vector plus b vector, c vector and d vector. Okay, so according to this, a plus b plus c plus d is equals to 0. So a vector is equals to b vector plus c vector plus d vector. Okay, so taking modulus on both sides, we get a vector is equals to b vector mod of b plus c plus d vector. Okay, this is the equation 1. So equation 1 shows that the magnitude of a is equal to or less than the sum of the magnitudes of b, c and d. So hence the magnitude of vector a can never be greater than the sum of the magnitudes of b, c and d. So option C is also correct. Okay, so statement D says b vector plus c vector must lie in the plane of a vector and d vector if a vector and d vector are not collinear, and in the line of a vector and d vector if they are collinear. Okay, so for so according to a plus b plus c plus d is equals to 0, then a vector plus in bracket b plus c vector plus d vector is equals to 0. So the resultant sum of the three vectors a and b plus c and d can be 0 only if b plus c vector lie in a plane containing a and d, assuming that these three vectors are represented by the three sides of a triangle. Okay, so if a and d are collinear, then it implies that the vector b plus c is in the line of a and d. Okay, let's let, let's write it down. If a vector and d vector are co-linear, then it implies that the vector b plus c vector is is in the line of a vector and d vector. Okay, so this implication, bigger button, this implication holds only then the vector sum of all the vectors will be 0. Okay, so option bigger button statement D is also correct. So what is asking here, which of the following statements is not correct? So our option A is the correct answer. Thank you.